Have you ever stood under a perfectly clear, dark night sky and just listened? It seems silent, right? A vast, quiet emptiness. But what if I told you that space is not silent at all? What if it's filled with a symphony, a chorus of cosmic frequencies that our ears just can't hear? Today, we're tuning into the universe's hidden playlist. Our journey begins with a concept called sonification. It's a bit like translation. Scientists take data that isn't sound like light, magnetic fields, or plasma waves and convert it into audible frequencies. They assign pitches and tones to different data points, transforming silent information into music. This isn't just for fun. It allows researchers to hear patterns and anomalies that might be missed by just looking at graphs and charts. It's how we can listen to the secrets of the cosmos. Let's start close to home, with our own sun. We see it as a bright, silent ball of light. But through sonification we can hear its true nature. Its surface is a turbulent sea of plasma, constantly bubbling and erupting. When we translate its magnetic field data into sound, it's not a gentle hum. It's a deep, powerful, almost intimidating roar, punctuated by crackles and pops that represent solar flares and coronal mass ejections. It's the sound of immense power, a constant reminder of the star that gives us life. Moving outward, each planet in our solar system has its own unique voice. Jupiter, the giant of our system, is a fascinating case. NASA's Juno spacecraft has instruments that can detect the planet's powerful magnetosphere and the charged particles trapped within it. When sonified, these signals create an eerie, otherworldly chorus. It sounds like something out of a sci-fi movie, a haunting blend of whistles, chirps, and deep drones. It's the sound of auroras 100 times more powerful than our own northern lights, a testament to Jupiter's immense magnetic influence. Saturn, famous for its rings, sings a different tune. The Cassini spacecraft spent years orbiting Saturn, and one of its most incredible discoveries was the interaction between the planet's radio waves and its moon, Enceladus. When converted to sound, it's a dynamic, almost rhythmic collection of shifting frequencies. It's as if the planet and its moon are having a conversation, a celestial back and forth written in plasma waves. It's a sound that's both strange and beautiful, a complex harmony created by gravity and magnetism. But what about the space between the planets? Is it empty? Not at all. It's filled with a solar wind, a stream of charged particles constantly flowing from the sun. When this solar wind interacts with a planet's magnetic field, it creates what are called whistler waves, sonified. They sound exactly like their name suggests. A descending whistle, like a tiny bomb falling through space. It's a constant, subtle sound that fills our solar system, the background music to the planet's grander solos. Let's venture further beyond our solar system into the deep expanse of interstellar space. Here, the symphony becomes even more exotic. One of the most rhythmic sounds in the universe comes from pulsars. These are the super-dense, spinning remnants of massive stars that have gone supernova. As they rotate, they emit beams of radiation from their poles, like a cosmic lighthouse. If one of these beams sweeps across Earth, our radio telescopes detect a regular pulse. When we sonify these pulses, they become the universe's metronomes. Some pulsars spin hundreds of times per second, creating a high-pitched, steady beat. Others are slower, producing a deep, deliberate rhythm. Each pulsar has its own unique tempo, a consistent beat that has been ticking away for millions of years. Listening to a field of pulsars is like hearing the percussion section of the cosmic orchestra, a steady driving rhythm that underpins the entire galaxy. And then there are the black holes. We often think of them as cosmic vacuum cleaners, silently devouring everything around them. But in 2003, astronomers studying the Perseus galaxy cluster made a stunning discovery. They detected pressure waves rippling through the hot gas surrounding a supermassive black hole at the cluster's center. These waves were, in essence, a sound wave. The pitch was incredibly low, about 57 octaves below middle C, far too deep for any human to hear. But by raising the pitch trillions and trillions of times, we can finally listen to it. It's a deep, resonant, and continuous hum. This isn't just sonified data. It's an actual sound, the deepest note ever detected in the universe, emanating from one of its most mysterious objects. It's the bass line of the cosmos. Even the birth of the universe itself left behind an echo we can hear. I'm talking about the cosmic microwave background, or CMB. This is the faint leftover radiation from the Big Bang, a snapshot of the universe when it was just 380,000 years old. Initially, the universe was a hot, dense soup of particles and radiation. This created sound waves, or pressure waves, that rippled through the primordial plasma. As the universe expanded and cooled, these sound waves were frozen in place, imprinted onto the CMB. Scientists can analyze the tiny temperature fluctuations in the CMB and reconstruct what those first sounds were like. When sonified, it's a strange descending roar. It's the sound of an infant universe, a cacophony that would eventually settle down to create the galaxies, stars, and planets we see today. It's the opening chord of the cosmic symphony. So, why does this matter? What do we gain from listening to these cosmic frequencies? For one, it gives us a completely new way to experience the universe. It connects us to these distant, abstract concepts on an emotional, visceral level. Hearing the roar of the sun or the beat of a pulsar makes them feel more real, more tangible. It transforms cold data into a powerful experience. It also helps scientists make discoveries. The human ear is incredibly good at picking out patterns, sometimes even better than our eyes or computer algorithms. By listening to the data, astronomers can identify subtle changes or unexpected rhythms that might signal a new discovery. It's a powerful tool for exploration, turning the entire universe into a laboratory we can listen to. The next time you look up at the night sky, remember that it is not silent, it is alive with sound. It's filled with the deep hum of black holes, the rhythmic beat of pulsars, the eerie chorus of Jupiter's auroras, and the ancient echo of the Big Bang itself. It's a hidden symphony of incredible scale and complexity, playing out across billions of light years and billions of years. We just needed to learn how to listen. Thank you so much for joining me on this auditory journey through the cosmos. If you enjoyed this, don't forget to hit that like button and subscribe for more adventures into the wonders of our universe. Let me know in the comments which cosmic sound was your favorite. Until next time, keep looking up and keep listening.